Present the entire screen.
Just a minute.
Yeah, it's coming. Yeah.
Okay. So before dealing with the actual AI applications, let me tell you why we are using Python. So there are a number of programming languages, right? So we are all acquainted with the languages like C, C++, Java, all these things. And also now the new language is Python. So what is the advantage of Python? Why we are using it? So the advantage of using Python over C, C++, COBOL, all those things is that it's an interpreted programming language, as you can see here. So and also, so what is the difference between an interpreted language and a compiled language? Compiled language are the C, C++, COBOL, all those are the compiled language. So what is the difference between the two? So as you can see from this chart, from this flow chart rather, so C, C++, these languages, those actually are actually they compile in the machine code and then they get ready to run. But Python is very much user friendly. So how user friendly? Like if you suppose say you want to do a summation of two numbers, 5 plus 3, right? So if you type 5 plus 3 and then press enter, you will obviously get 8. But the same thing is not applicable to C, C++. For that, you have to build a class, suppose class A or class B, something like that. Then you have to call the void main function. Then you have to do assign to variables A equal to 5, B equal to 3, then C equal to A plus B. Then you have to print it separately. So all these things, it needs to be written in the machine code and then it gets ready to run. But that is not the thing for Python. Now, also you can, if you see, it is free and open source. Open source means you can download it from online anywhere. Like if you download from python.org, you can automatically go there and download according to your computer's version. And also there are packages of Python in Anaconda. All it is actually distribution of Python. So there in anaconda.exe, that is also freely openly available. So there you can find the different packages of like IDEs. What are IDEs? IDEs are the integrated development environment. Like I am doing in Jupyter notebook. You can see at the top it's written as Jupyter. So this is actually a Jupyter notebook. Similarly, I think Ankurji will also be showing you in Google Colab. Colab is an online notebook and mine is an offline notebook. So if you don't have an internet connection, you can easily implement the codes in Jupyter notebook. And also there are other IDEs like PyCharm, Spider, but compared to Spider and all, the advantage of the notebooks like Jupyter and Google Colab is that you can implement the codes in segments. Like you can check a part of your code whether it is correct or so. That is the biggest advantage of this Jupyter notebook and Google Colab. But that is not possible in case of Spider. Now, the two most important things that you need to know are before doing the programming is our TensorFlow and Keras. So what are these things? TensorFlow is an open source machine learning platform where you actually write your code, right? So I think many of you have heard of it, this TensorFlow and Keras. So Keras is also a deep learning library, but if you see, it is an application programming interface which is also written in Python, but it is built on top of the TensorFlow. So what is meant by built on top of TensorFlow? Means from TensorFlow you need to for doing the basic operations like addition and subtractions and everything. So the libraries that you need to import, all those will be imported from TensorFlow. But there are certain specific deep learning libraries which will boost your working of the AI algorithms, like LSTM, which Ankuji was mentioning few minutes before. So CNN, those things directly, those are already, you have the models inbuilt in Keras. So you just, it is very easy. There is no rocket science in it. You can just import the model, and you can just import, you just tune the model and based on your requirement, and then you run the code. Okay, so there are different libraries, as you can see, like NumPy, Pandas, Seaborn, Scikit-learn. These are the different libraries. What is Pandas? Import Pandas as PD I have written. So what is Pandas? Pandas is nothing but panel data. Okay, and NumPy. NumPy is nothing but numerical Python. So you can see that all the these. Yes, somebody is asking anything. Okay. Hello.
Yeah, go ahead, Pritamji.
Okay. So these are the different libraries that you are importing. You need to import before actually you implement your algorithms. Now, so you can see import pandas as PD. Now, what is PD and what is NP? So NP and PD, when you are doing some array operations or some anything mathematical operations, so you need to import. I told that you have to import them from TensorFlow, right? So if you need to import them from TensorFlow, how many times will you write numpy dot array this, numpy dot sum this? So this is not so to shorten that, you have written it as NP. Now these are conventional short forms, NP and PD. You can write as import numpy as AA or BC or CD, EF, like this. You can write anything. It's not mandatory that you have to keep as NP or PD, but it's convention. So next, if you want to check the Keras version that is installed in your machine, so just write import Keras. It will automatically now before writing now you can see that I am working on an environment like localhost, notebooks, this thing. So this is, don't think that although this is a browser based, but this is, don't think that this is an online thing going on. This is an entirely offline thing. I have just installed Jupyter notebook in my machine from Anaconda software, and then after I installed, automatically I clicked on that Jupyter notebook, and this, after this has come, I have developed my codes. Okay, so these, as you can see, this 1, 2, 3 at this sides, these are the different segments where you write the code. These are actually code snippets where you write a portion of your code and finally check the output. Like I want to in one step I want to just import Keras and then Keras.version. I to check the Keras version, I get the Keras version that is installed in my machine. So you can see that when I have run it, at the bottom it is written as using TensorFlow backend. As I have mentioned that Keras is built on top of TensorFlow, right? So automatically when I am importing Keras and checking the version, so as TensorFlow is there on the backend, so it is automatically taking using TensorFlow backend. Similarly, I want to check the TensorFlow version. So import TensorFlow as TF. So TF is also again not mandatory. So you can write any keyword here. But TensorFlow, Keras, these are the keyword, pandas, numpy, these things, these names need to be specific to you. So TensorFlow, I am checking the version that is installed in my machine. So it's 1.15.0, although higher versions are available. So I want to check the Python version that is installed in my machine. And one thing I want to tell you all that all these codes, don't think that you need to remember all these things. Okay, so just Google that I want to check the Python version of my Jupyter notebook. Then what will be the so nowadays everything is available. You don't need to. The biggest advantage is that you don't need to remember anything. So, and also it is easy to implement. Okay. So now I will be describing, telling some of the data structures actually which we require while dealing with actual AI. So in the big code, as a part of it, so you encounter a number of data. You have to handle a number of data structures. So there are different data structures like list, tuple, and dictionary. So what I will be describing the difference between all these three. So if you see, I have written that list, 5 numbers are there: 20, 30, 40, 50, and 60. Okay. So if I list is actually not mutable, sorry, it's mutable, but the structure, the elements, only certain operations can be performed. Like you cannot add or multiply any number. You can just insert something, you can pop up something from a list. And see, if you want to check what are the operations that are available with in the list, you just put my list dot and then there's a tab here. Just a minute. I think I need to, yes. See, I pressed tab and you can see the comments that are available with that you can do with a list. You can append, you can clear some number, you can copy some number, count, extend, index, insert, pop, remove, reverse, or short. Okay. So let me choose append. So you can see that my list is having 20, 30, 40, 50, and 60. So let me append 6. So I am running it. See, the output is, now I have to check my list. See the output: 20, 30, 40, 50, 60, and then 6 has been appended. Okay, at the last. Next, suppose you want to print certain positions. So from the index 0 to 0, the first index starts from 0. So 0, 1, 2, 3, and 4. So when you will see that 0 to 3, every time it will print to some position just exactly before to that. Means from the indexes 0, 1, 2 will get printed. So I'm running it now. The 20, 30, 40 have got printed. So 0, 1, and 2. 3 elements have got printed. So similarly, if you would want to see print from position 2 onwards, from position 2 means if you want to then you will give the position and then a colon. So 0, 1, 2. So it will print from 40 onwards. So let me run it. See, 40, 50, 60, and 6. So these are the different positions from 2 onward, or from position 2 onwards you will be printing. So these are some of the syntaxes that you need to remember. Now one of the biggest advantage of a list is that you can inside this particular inside a list, you can list different types of data types. Like it can be an integer, it can be a string, it can be a float variable, anything. Whereas in an array, that is you cannot have this advantage. In an array, all the data types need to be of same category. Like if like all the variables need to be either integer type or float type or string type. So if you list means you have to list, like when you go to the market, you make a list of what are the things that you need to purchase. So similarly, but all of the things are of different categories, right? Like you have to purchase fruit, you have to purchase your the dal, you have to purchase the almonds and many things. So these are of different categories, right? So oil, everything, so not of the same category. So for that reason, when you can list them. Now tuple is of similar category as a list. Here also you list them, but here you don't get the advantage of muting something. I mean, it's immutable. You cannot change, you cannot append, you cannot clear as you have done in list. So list is so tuple is immutable. The only thing you can do here there are two options that you can do. Let me run and show you. So this is my tuple you have run. So now let me run my tuple dot. Then when I click on tab, then you see there are only two options available. Only you can count the occurrence of a particular number, and or you can locate the index of a particular number. So let me give count. Suppose you want to count the number of occurrences of the number 2. Okay, so it should come as 1. See, it has come as 1. So how many times this 2 was occurring in this tuple? Only one time. So this was an advantage. So next comes the dictionary. It is another data structure like list and tuple. So dictionary, it's a collection of key value pairs. Like by pointing to a key, you can point out to all the other values. Like say Virat is the key. Then under Virat, you have the values as captain and batsman. If you have Rishabh, then under that you have keeper and batsman. Then if you have Jasprit, then under that you have the value as bowler. Next, if I refer to the dict key, key is Virat here. So if I run it, you will be getting batsman and captain. Similarly, let's say if I write here Jasprit, you will be getting options bowler. So you can refer to some key and get the all the values listed under that. So this is actually beneficial when you handle large data sets by looking at their keys. It's like a dictionary. The name itself suggests that. Like if you search by the letter A, you will get all the letters with A under that. With B, all the letters, all the words with B under B. So similarly, now if you dict.keys, if you want to see all the list of keys, so then in that case you have to do this dict.keys. Similarly, dict.values, you will be getting the values under the keys, right? So the most important thing that also that you need to learn is how to handle a data set, right? So you have a data set. There are many data sets available which you need to process and generate your model. You need to train and develop your test your algorithm on that. So for that, you can see that a number of CSV, it's generally available either as CSV file or as a text file or any other format. So I have some data listed with me, a solar power plant generation data. So for that, the command is pd.c, pd I have used here, pd.read CSV, plant 1 generation data.csv. So it's a CSV file I am reading. But if I would not have kept PD, I could have written here as pandas.read CSV. So it's panel data, it's reading the data. Now I have loaded the data set. Now there is a command. So the name of the data set is df, right? So I have read the data. I've kept the data set under df. Now df.head, if I do, you can see that I have done here 21 before. So if I do only df.head, what will happen? Only the first 5 first 5 rows will appear of the data set. See, only first 5 rows have come. So you can do here df.tail also. In that case, the last 5 rows will come. The last 5 rows, see, you can understand by the indices. So there are 68,777 rows of the data. So it's a plant generation data set where we have the features like date time, the plant ID, the source key, the DC power generated, the AC power generated, the total, the daily yield, and then the total yield. So these are the different features of the that has been that were available in the data set. Now, if you want to check the what is the this data set, what is it actually, means whether it is a list or what format it is saved in many a times you will find that the data sets are in 3D format, right? So when it is a 3D format, you need to structure the data accordingly. So for that, I'm coming afterwards. So first let me check what is the, so handling with 2D data is not a big issue. So either your data are 1D or 2D, but when it is becomes into 3D, so you have to, so the main time that the data scientists devote on are on the, I mean, structuring the, like analyzing the data and structuring it so that that can be appropriate to be fed to some particular algorithm. Okay. So type.df, when I do it, you'll see pandas.co.frame. So it's a data frame. So it's giving the structure as data frame. Similarly, when I do df.shape, so here it will print the size of the data shape, the data frame. So it's rows, comma, columns. So 68,778 rows, comma, 7 columns. So 68,778 because it started with 0 and ended till 68,677. So all you can see that it's the I mean the logical operations, everything is based on statistics. You will also see that statistics and probability and linear algebra, all these things are the key things that involve that are mainly required for building an algorithm. Now df.types. So I have I want to see when I see type df, so it will give the entire, what is this entire CSV file actually. So there, that is actually a data frame. Now if I want to study the, I want to understand what are the different column data are of type, are of what type, if I want to know. So it give, I will do df.dtypes. So in that case, so so in that case you will see that date time, plant id. So date time is a type of object means here actually it's a string, and then plant id. So plant id is actually of integer variable. Then source key you can see it's a string category, so object. Again float, dc power, ac power, daily yield, total yield, so there is decimal thing, so all are of float time. Okay. So now if you see that the date time was detected as an object. So first my date was written and then the time when the plant data was acquired. So these two things were there. So it was in the object format. But for my program to run, if I require it to be in the numerical format, then what to do? So in that case, I will again call PD pandas. So df, then inside bracket you will write date time, then you will do pd dot to date time. Okay, to date time means it will convert there is a format of date time, to date time, which will convert it into the integer category. So which you are converting, so inside df date time you are saving this this date time, the object one, this one. So convert object date to time format. Okay. So if you do that thing, you will also get the result. Now if you check, the date time will be of this 64. It's actually also a category of integer category, like plant id, it's also an integer category. So similarly, some are of integer category and some, the others were as were they were before, of float category. So similarly, I am having the different other operations also, like be equal to some string variables, and if I want to check, I will get type B1, I am checking this element. You can see as we refer to string within quotes. So although these are numbers, but since they are within quotes and immutable, so I'm getting the type as string. But now if I want to get these string variables, this 1 to 3, if I want to convert them to numbers instead of strings, so in that case I have to do here just like I did pd.toDateTime previously. Here also there is a command like pd.toNumeric b, type b. Then if I am checking this numpy.ndArray. ndArray means an array of integers actually. So now I am again typed b. See, it's giving the variables 1 to 3, and data type also it's giving as integer, whereas previously when we checked that was a string variable. Now when you check the data, the type of a particular column, so the entire thing was a data frame, right? I mentioned previously, I showed you. But if you want to refer to any of the columns particularly, so in that case you just refer to it by the name df, and then within that particular index. So in that case you will get it as a pandas.code.series. So it's a series, not a data frame. So every column is individually a series, okay, and the entire thing is a data frame. So now let me discuss something on arrays. So these distance equal to distance and speed. So we know that there is a speed time distance relationship, right? So speed equal to distance by time. We all know that. Now, if you do, as I mentioned earlier, that lists are the mathematical operations, the like addition, subtraction, all the division, multiplication, those you cannot do with list, but those can be done with an array. So if you have a list of distance like 90, 80, 70, 60, 100, then speed 23 for these values, then if you check the type of distance, you will see that it is a list. Let me run it. So it's giving a list. Now similarly, if you do, let me do some mathematical operation on it. Insert cell above. So let us see what happens when we divide this by SPD. So you will not get a result here. Distance by speed. So you will get an error because unsupported operand types list. So this division will not occur here. It's being shown as an error, right? So for that reason, to do the division distance by speed to get the time, you have to convert them to arrays. So np, how to convert them to arrays? So you will do np.array this distance, and then check the type within the variable dist. I saved this array now. So the distance array. So if you check, you will see that it's an ND array. Now similarly for speed also you are doing it. Now if you do dist by so dist and speed, these are my two variables. So if you do the division, you will be getting the results. Okay, so I have shown you that the mathematical operations you can do with an array but not with a list. Only lists are used for storing the data, right? So list, tuple, dictionary. So len is a command for checking the length of the array. Now here also see, I have done two conversions. So the first bracket, these are actually used for representing tuple, as I have shown you earlier, and the third bracket, these are the third braces, these are used for representing a list. So this f and g within these two variables, I want to convert both the list, the tuple and the list into arrays. Sorry. So if you want to do the conversion, so for that reason, from tuple to array, you are converting np.array. Similarly, list also you are converting np.array. And now you can print these operations. So you are doing a summation, and then you are doing multiplication. So anything you can do with this after converting into an array. Now, there is a command called to generate the numbers automatically. So you suppose you want to generate 10 numbers, right? So for that reason, for that reason, suppose you want to generate 10 numbers. So 0 to 9, the first 10 numbers or the natural numbers will get generated automatically. Okay. Similarly, if you do np.arange 5, 56, and 5, it will take a gap of 5 and print till it reaches 56, and it will start off from 6. So np.arange 6, 56, 5. So 6, 11, 16. So see, it is starting off from 6, first this one, then with a gap of 5, it is typing 11, then with a gap of again 5, 16. Like this, it will continue till 51. Only the last number will not get printed. So after 51, if you type it becomes +5, it will become 56. So it's the last number, so it will not get printed. Now, as I told you earlier, that the main thing is handling the data structures. So you may have the data in a 3D frame. So I'll be showing you the 3D and the 2D shapes that are available. So suppose you have a 1D array. Okay, so this in the 1D array under the thing called data. So you want to convert this 1D array into a 2D array of shape that is having 8 rows and 3 columns. So this will have this 32 to see the same elements are here, but it's a 2D array. Similarly, if you want to convert the 2D array into this 1D array into a 3D array of, means in 3 dimensions, right? You see 2, 2, and 6. So 3D matrix. So you will get this thing. So there are some other commands also, like np.zeros to you can get a zero matrix, an array of zeros. np.ones, if you do, you will get an array of ones. And then so, but inside np.ones or np.zeros, you have to specify how many ones or how many zeros you are getting. So, but don't think that like zeros and ones you will get np.twos or threes like this. This is only, you can get only for zeros and ones. Okay. So similar, and after you do this np.ones, since you are having numpy, this np here, so these are, you can add with them anything. So np1, you will be having an array of ones, 10 elements, 10 number of ones you will be having, and then you can, if you add +5, you will obviously getting, so 1 + 5 6, 1 + 5 6, like this 10 elements you are getting. Okay, so here np.diagonal. So the diagonals, if I specify the np.diagonal, just like np.ones and zeros, you will be getting some square matrix with the diagonal elements only. Okay. So next comes data visualization. So those mathematical operations that I have discussed so far, so those you don't need to remember. Again, I am saying, you can those everything just based on your purpose, how to type the diagonal in pandas and numpy in Python, or how to do add, just type this in Google, you will automatically get these comments. Okay, as I just showed you, because these are important in terms of while handling the data, means the data structures rather. So now data visualization. So for data visualization, I talked of some of the libraries a few minutes back, like Seaborn, Matplotlib. So these are actually, these pandas and NumPy you already know, but but these matplotlib and .pyplot and seaborn, these are for visualizing the data. So let's we have already shown a data set, right, of the plant's solar power generation thing. So if you want to visualize the histogram of a, so histogram is for the univariate data. I will be showing you for bivariate and multivariate also. So how to visualize that thing. So data visualization, this also data scientists and the people who work with the data, so they need to understand very well first before implementing their algos, because until and unless you understand the data structure or you are unable to visualize the data, it's quite impossible to run an algorithm, because algorithm is not a big issue, okay, because the keras and because of the keras and TensorFlow, you already have those inbuilt models. You can both machine learning as well as deep learning, you can import them, and but before that, before feeding to them, you need to structure your data. So that's why I am discussing all these things. So data visualize, when you want to visualize an univariate data, so you will just give the comment SNS does dist plot for doing a univariate data histogram thing. So on the histogram thing, you can also see the density estimate, the PDF here. So in that case, you will write for the DC power generated. If I want to see the what are the values of the DC power generated, how many of them are there. So so I can visualize that, and I will just call that particular variable by df dc.power. Then kd equal to true. What is kd equal to 2 means your kernel density estimate. If you can see this thing, this kernel density estimate is visible because kd equal to 2. But if you make this as false, you'll only get the, I made it false. See, you will not get the thing. Yes, this one. So I put it as false instead of, you are just only getting the histogram. You are not getting the density estimate. So next comes the bivariate thing. So suppose you, for a particular date time, you want to visualize the count. Okay. So this, just a minute. Sorry, not bivariate. This is also for the date time thing. Here also, here just getting the a bar chart actually. So for visualizing the histogram, you have to give the command as dist plot. Okay. But if you want to see a bar chart, you will give a count plot. So same thing you are visualizing. So I have taken df.head 80, means for the first 80 rows, I have considered the date time. So on the x-axis, you are getting the date time for how many date time values are there. For means on every day, you are getting a number of values, right? So this is the count of the values that you are getting on the first 80 rows for each day. So this is for a bivariate analysis. Here you are actually getting a regression plot. Ankurji, I think we'll be discussing the regression thing with you in details. So here on the y equal to mx plus c, we all know that, right? So for that thing, on my y variable, there is on the y-axis there is my daily yield, and on the x-axis there is my AC power. So I will be getting this thing. Similarly, for a multivariate thing, I will be getting, if I want to, like y equal to m1 x1 plus m2 x2, like this, if I get for multivariate things. So multivariate linear regression. So on the y-axis, you can see that there are daily yield on both the plots, but I am using the same thing. See here two, but I am dividing how many subplots I can visualize. So 2 rows and 2 columns I have fixed here, and also the figure size, the dimension I have fixed 10 cross 10. So it will be a square size, 10 cross 10 dimension. So these things you can fix. All these comments are available. So for I in range, this is a for loop actually. For loop we all know, but it is applicable either in there are differently the same thing, the concept is same, but the language is different, the way you have to implement it in MATLAB, in Python, in C, C++, but all of them have for loop and while loop. So the main, if anybody of you knows one programming language, learning Python is not at all a big deal. You can easily implement. Only some codes and some libraries you need to know. Some keywords, like here for regression plotting, you need to know the SNS dot reg plot. From SNS means like import seaborn as SNS. SNS I have used here. So here on the X column, on the X, you are writing pow call I. So what is pow call? Pow, see 0 to len pow call. Here pow call is having column name. For column name in df dot columns. So which columns? If power is there in the column name. So how many columns have power in their names? Only DC power and AC power, right? So if you visualize the data set once more, let me show you the data. Yes. So here you see how many of them have power in their names. Only DC power and AC power. The others are having yield or source key or plant ID. So only AC power and DC power will be plotting. So you are plotting what? You are plotting on the y-axis this daily yield, and on one graph there is AC power, and on another column on another x-axis there is DC power. So don't think that all are zeros here. Okay, so I just 5 rows and the first 5 rows and first 5 column, the last 5 rows are visible to you. There are many rows that are in between these 4 and 6, 8, 7, 7, 3. Okay. So now let's come to the actual thing that you must be waiting for. So this machine learning and deep learning, right? So those I showed you the how to handle the data structures and how to handle the data visualization. So all these things now will be required in machine learning and deep learning. So what are ML and DL? So these are actually the subcategories of AI. Okay, so ML and DL, both of them, they actually are certain algorithms which either do some classification task or they do some regression task, like the power data that I have shown you, the daily yield, that is nothing but a regression thing. Okay, so that is a regression task. So classification or regression, and so these classification and regression, these are applicable when you have some specific output levels. Okay, specifically classification, like which class, from the word classification we can understand whether suppose the class 0 or class 1 or class 2, 3 classes are there, which class my data belongs to. So if you want to segregate your data, so for that you can use the ML algorithms. Now another type, DL, deep learning. So deep learning is another subcategory of machine learning actually, but deep learning, you can see from the name deep. Okay, deep is used because of the depth of the neural networks. So we all know, I think you all have heard of the term neural networks, right? So if I assume that you all have heard that term neural networks, so what is that actually? Like suppose a baby, a newborn, a baby, when he or she is born, so his parents, his siblings, they give him or her some trainings, right? So he or she learns as he or she grows up. So while growing up, he learns which is a house, which is my mother, which is my father, which is my brother, which is what to eat, which is some food or which to eat and which not to eat, which is good and which is bad. So all these things, he or she, the baby learns while getting. That is actually a kind of training he or she is receiving, right? So that training happens for a particular period of time, and after that, when he or she gets accustomed to all these things, you don't need to tell him what is good or what is bad. He or she can automatically understand which is good and what is bad. So the first phase, when his parents and his siblings, they are training him or her which is good and which is bad, so that is called the training phase. Okay, So similarly, for an ML and DL algorithm, these are actually the DL algorithms, the deep learning. These are based on the neural networks. So in human beings also, or in any living creature, you can see that there are,
Hello,
neuron.
Pritam ji.
Huh.
Pritam ji, you can hear me, right? Some
Yes, yes.
people are saying no audio. Is it happening with all the participants?
No, no, it's audible.
It's audible. Okay, okay. Go ahead. Go ahead then.
Okay, okay, okay. So, so if you see the persons, so in his or her learning phase, so they are getting trained first. Similarly, based on the neural network, the nervous system, the neurons that are inside the human beings or any living creature. So similarly, these artificial neural networks, those are the backbone of the deep learning. So there also you will be having some kind of models that will get trained through the automatical through the neurons, and after the model is getting trained, you can feed it to some you can use for testing some unknown data on it. So you can see the advantage of DL, deep learning. You will import model from Keras, here, the Keras library, feed data, tune it first. Accordingly, you have to tune. See, this tuning, this hyperparameter tuning, there are some parameters like how much, the number of neurons, what we will keep. Whether you will keep it is 5 or 10 or 15, that you need to tune. You have to understand. While you will understand that how much accuracy is you are getting while training it, learning rate, and all regularization. So these are the different tuning parameters. I'm not detailing it, but you need know that you have to tune the model after you feed the data to the model. Then you will run after tuning it, you will run it and get better results without separately extracting the features. Mostly means why I have written without separately extracting features, because for machine learning algorithms you need to analyze the feature, you need to do feature select, which feature is best. Some there you can find that while learning machine learning, that there are many features which are bad and there are many features which are beneficial for your algorithm. So you need to segregate them. So there are mathematics like eigenvalue, principal component analysis. So those things, those mathematics are the backbone of the machine learning, those understanding of feature extraction thing. So those things you need not to do with deep learning. So just deep learning is very easy. You just import the model, feed data, tune it, and run. So just I will show you a simple neural network classification. So a simple neural network, I have classified, I have used the PIMA Indian database, diabetic and non-diabetic. So there are 8 input variables, okay, 8 features rather. 8 features are like, based on that, you will understand whether the patient is classified as diabetic or non-diabetic. So input variables are number of times whether the patient was pregnant, the plasma glucose concentration at 2 hours in an oral glucose tolerance test, diastolic blood pressure, triceps in skin foldness thickness, 2 hours serum insulin, body mass index, diabetes pedigree function, and age of the patient in years. So these are the 8 variables. So the numeric variables you are having, and then based on these, you will predict, you will classify whether the patient is diabetic or non-diabetic using a multi-layer perceptron or a neural network, simple neural network. So I'm not going into very detailed. So see, the classification output will be either 0 or 1. So here, see, I have written a code from numpy import load txt. So inside load txt, you will just load txt, the data set. I'm having the data set named as PIMA Indian diabetes data.txt. So, and you can see the delimiter comma. So inside the data set, actually all the variables are written by comma. So I have already initially run it. I will again run it again. These are the different numerical values corresponding to all those 8. See, 6, 148, 72, like this. So comma. So you have to understand those particular numbers. So that's why I have to use the delimiter. Then X, you have to import the input data. So for importing the data, you have to split those data. So obviously the data set won't understand itself. It's not that much intelligent that it will understand which is a variable and which is what. So you have to put that intelligence this artificial intelligence into your model, right? So for that reason, you have done this data set, this from this colon, comma, 0 to 8. First, this colon means all the rows are considered inside the data set, data frame. Comma, 0 to 8 means from the first 7 columns first 8 columns you are considering, from 0 to 7. The last is not considered, I told you earlier. So 0 to 7 is 8. So 8 for 8 input variables, you are having this thing. Next, y is the output. Or again, here all the rows, the last column is used for the classification into 0 or 1. So the 9th column actually of the data set. So here you can see this, 6, 140, 72, 35, 0, 33.6, 0.67 and 50. Similarly, all 5 rows are there. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 input variables corresponding to that. The 9th column, this 0, 0, 1, 0, 1, this is your output variable. Okay. So now the deep neural network that I am coming into. Define the Keras model. So for that, you have to inside model just write sequential. Okay. So sequential you have to import from keras.models. Again, you are importing this from Keras. Import sequential. Whatever deep learning model you are going to implement, just import sequential and import another thing called dense. So dense layer is the dense means how many number of neurons are there in that particular layer. So you can understand from here, if you see, first I am assigning the model to be a sequential one. Okay. Then 1, 2, 3 model.add, model.add, model.add. Okay. So means there are 3 layers after the input data. Means this X data set 0 to 8, this thing, it is getting inside this, getting fed into this model, which is having 3 layers. So the first model.add is having 12 neurons whose dimension is 8, and then activation function ReLU. Now, what is this activation function? So now input dimension I think is 8 is because of that. I can say that this is because of the 8 input features. Okay. Now what is activation function? Activation function, there are many activation functions like ReLU, sigmoid, many others are there. So softmax. So this thing you need to decide. So deciding the activation function, that is the main problem of a deep neural network. And also assigning these numbers, see this 12, 8 and 1 dense. The first thing, how many neurons will be there in this particular layer, this model dot this. So I told there are 3 layers, first layer, second layer, third layer. Add dot, add dot.
Pritamji,
Yes.
sorry to interrupt. Somebody is asking that 12 means. What does 12 means here?
Okay, 12 is the number of neurons. 8 is also the number of neurons, and 1 is also the number of neurons in the corresponding layer. So first layer will be having 12 neurons. Okay, this thing I told that it is a hyperparameter which you need to decide. You can first, it's not mandatory that you have to put it 12. You can put it as 5 also. You can put it as 10 also. But after you train your model, just see when you are getting the accuracy maximum. So based on that, you have to put the numbers where when you are getting your accuracy maximized. So this thing is called as hyperparameter tuning. Okay, so I think the question is clear to him or her, right?
Yes, Pritamji, yeah.
Okay. So similarly for the second layer, here is no input. The second layer is getting the input of the first layer only, this model.add. So that's why you don't need to give the input dimension separately. In the first layer only you require input dim. Okay. So in the second layer, you just need to give the number, you need to specify the number of neurons and then give an activation. So choosing the activation function and choosing the number of neurons, this you need to decide. Okay. But the number of neurons that is present at the output layer, this thing is fixed based on how many means what activation function you are using and how many number of classes you are wanting to predict. So it is predicting either as 0 or 1. Okay. So when the activation is sigmoid, so it will predict as either 0 or 1. So there will be only one particular output, means whether the patient is diabetic or non-diabetic. So one output. So that's why the output is 1, this dense 1. Okay. Now I can say that if I want to see both outputs, I mean, there are, suppose in a data set you are having 5 categories, A, B, C, D, E. You want to get one of the outputs. So in that case, the activation sigmoid cannot be used. Okay. So in that case, you have to use the same thing for where the number of variables at the output is more, the number of classes at the output is more than 2. In that case, activation you have to use softmax. Okay. You can search Google by typing the name softmax, 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 same as sigmoid, but sigmoid is for a binary thing and softmax is for a multiple thing, means multiple output thing. So
Pritamji,
next,
sorry to stop you again. There is another question from Mahesh Naik ji. He's asking, is it possible to show the structure of this model graphically? He is asking, can we visualize the layers?
This thing, sigmoid is sigmoid. Do you want to see sigmoid or the entire?
I think he's saying that can we visualize the layers, right? Mahesh Naik is asking that you want to, yes, entire model, yes, entire model he wants to see.
For that reason,
you have the first layer had 12 neurons, and then because
yes.
Yeah,
so that for that thing, this since this is actually an entire program, so I can tell you the particular comment for by using which you can visualize the entire model thing. The thing is model.summary. Okay, just you remember, or you can type in your code. I will not be able to run now because I have some other things also
fine.
to.
Mahesh, actually, this model.summary will tell you all the details of the model, but
I have this
for
thing.
graphically, Pritamji, can we analyze this?
Graphically, I think there is you can just pictorially represent the
Yes.
thing, how many number of things, but graphically the number of neurons that actually are people draw by hand. Okay, so that is that this mathematics, how many things.
So another way here, just to add it, exactly, Pritamji is right that you can see the summary, but what you can do is, at each stage, if you want to see the output of your input data, let us say it is more clearly visible in case of pictures data or images data.
Right,
there you can see, let us say you want to predict that whether this is a car tire or not. So you might be starting getting a bit of shapes, circular shapes or haphazard shapes like that. So you can do it, but you cannot really see inside what's actually happening. That's why this is deep learning, and they say it automates it. But it's not a black box. What happens? Pritamji is clearly telling that you have these many neurons in that particular layer, and back propagation must be happening here.
Right.
That is why the loss is getting minimized, and you are very close to your actual value.
So I'm telling what is back propagation actually. So here, as I told you earlier, there are 3 layers. Okay, so first layer, second layer, third layer. Now, if you see the Keras library, you can go to the Keras library by typing keras.io. Okay, so inside keras.io, it's a website, keras.io. From there, from the Keras library only, all these models. Hello, is somebody saying anything?
Sir, I have a small.
Okay.
Sir, I have. Sorry for disturbing. So, softmax is actually a classifier. Am I right?
Right. Sigmoid also is a binary classifier at the last, right?
Okay. Then can we use SVM or random forest, anything for the classification instead of softmax?
SVM can be used instead of SVM is actually a classifier. It is also a classifier. You are very much correct. That is in higher dimension. Like if you want to do some classification in some higher dimension. So like visualize, if you do suppose you have a 3D data. Okay. So but you do to classify the variables, the samples in a binary layer. So how will you classify it using a line? So in that case, SVM you can use, support vector machine, by using a plane in a higher dimension. That you can do. But random forest and all those are actually the machine learning algorithms that you can also use as a
Yeah.
classifier. I think Ankurji will be
Okay.
discussing few
Yes,
machine
yes.
learning algorithms.
Just to
after.
add what you have told, madam, you have asked a very good question here. That can we use a classifier at the end along with our deep learning models? Yes, that's what many people are doing, and it is very much implemented in industries also. So what is the advantage actually? That is
Okay.
the key point here. When you use a deep learning model, it has already extracted the features which a normal machine learning
Right.
could not have done, right?
Right.
Now you have those features, and with a very simple classifiers, as you have told, like SVM or KNN or random forest or decision tree, we can now plot a decision boundary that can segregate. So previously, if I give you a very simple example here, so let us we have to classify between two types of dogs. Let us say a Labrador and a Vodafone puppy. I don't know the name actually. So when it will be little difficult because both are dogs. So manual feature selection might be little difficult here. But when you actually extract some of the features and then you feed to your simple classifiers, you will be getting a very high accuracy that this is a Labrador dog, this is a small dog, this is this type of dog. So this is actually a very advantageous thing. So this we actually do. You're right. Another question coming, Pritamji, let us take it. So how do we decide 12, 8, and 1? How are you deciding hyperparameters? Yeah.
So yes, I in the previous question also I told the same thing that these are actually the hyperparameters, the number of hidden layers. Then for a model you need to know the learning rate, then regularizer. So these are the things that you need to tune. So I told while studying the deep learning thing that you need to tune your model. So see, wherein lies the complexity of the model. You already have the model, okay, so we available with you from Keras, you can download, but this tuning is some automatic thing, and also numerous research works are also going on parallelly to how to this hyperparameter tuning. This is a limitation that people need to do it manually by trial and error, a brute force way that people need to do. This many number of neurons I am getting higher accuracy, the maximum. So let me give it a bit higher, make it a bit more, increase a bit more. So in that way you are increasing or decreasing. Only the last layer, as I mentioned earlier, the last layer is fixed, that you don't need to decide. But the intermediate layers, these 12 and 8, you need to tune it based on how you are getting the classification.
Yes, just to add on this, Swapnaji, it is like, it totally depends on your data actually. Data is the key thing here. For some data set, you will start with 64 and end up till 256 or 512 number of neurons, and you can go till hundreds of layers. If you Google just the architectures of VGGNet and deep ResNets, they are so deep layers because of you want to get the maximum accuracy out of it. So this particular tuning is in our hands. That's where research comes into the picture. And it also is, it is not just a black box. We see the data visualization is the key here. Whenever you get data, see whether this data has, we can go in, if it's a simple time series data, more number of layers might not be there. But if it's a cancer image data, those such of data, you go very deep to identify exact, you need a very, very high accuracy over there. So it's totally, manual thing, but we have some thumbs rules. We start with at times 2 to the power so that it suits the model and those stuff. You can Google those stuff, but yeah, it's a total manual thing, which people are working on that. Okay, just give the input and get the output. Some artificial intelligence tools have come like that. So this is like that. Yeah, Pritamji, carry on. Yeah, I hope we have any other questions on this, because we are getting a lot of questions on neural network model.
Yes, sure. Any other questions?
Because this is something which is actually the crux of any ML or DL architecture, the neural networks, which might have been, I think this will be taught to you also in detail here, and we have implemented it. So okay, Pritamji, go ahead.
Okay, so if you just see I added the layers. Okay, so this is the advantage of a deep learning model, that it is already inbuilt and you have to just import it. So dense I have imported from Keras. So dense is there. What is there inside dense? If you want to see what mathematics is there inside dense, you can easily see by going to keras.layers. Inside Keras, after you download Keras, inside Anaconda package, when you download Python, you will see that you have to import Keras also. So to train the deep learning models. So if you go inside the Keras folder, you will see a subfolder called layers. So inside subfolder layers, you will see that there are something called dense. So inside dense, you can have a look what is there inside that. So that will give you the mathematics thing. Okay. So here, this is actually a kind of thing plug and play. Okay. So model, you are just importing sequential, then you are adding the layers, and then model.compile. So you have to compile the model. You have just added the bricks to your house, and then now you need to put the whitewash and all those things. So model.compile. So I have, since it is a binary classifier, so either 0 or 1, so I have used the term binary cross entropy. If it was multi-class, like if there were more than 2 classes, 5 or 6 or some more or less, so in that case you would have taken the loss as categorical cross entropy. Okay, so by default the optimizer we have taken as Adam. There are different optimizer, means which actually control the there are certain terms like overfitting and underfitting of the model. So that you need to control, means like some bias variance term comes into play. Means like the thing I'm explaining this simply, like if you train a model on some data, okay, now if you give the same data for testing, you will give a high accuracy. You will get a high accuracy because it is already trained on some particular data, and you are testing on the same data. But if you see, if you test your model with some unknown data, which the model has not seen earlier, if it performs well, then the model is fine. But if it does not perform well, if it gives a very less accuracy on an unknown data, then there is a big gap between the training and testing accuracy curves. Okay, so that situation is called as an overfitting situation. Means you will perform well if you get the known questions in your exam, but if you cannot perform well if you get any unseen questions where you have to utilize your intelligence to answer some questions, some conceptual based questions. So if you cannot be able to answer well, so that is a condition called overfitting. Okay, so to prevent those situations, we use this optimizer. Sometimes we also use regularizer also. So Adam, by default it is Adam we have used. Now instead of Adam, you can use also, there are other optimizers like SPGrad and AdaGrad. Many others are also there. Okay, RMS prop, those optimizers are also there. But generally people go for Adams. Now metrics, what you want to get? Accuracy. Okay, so based on accuracy metric, it will do the classification. So after you have compiled the model, you need to feed the model with the data. So here you have built the model, here you have compiled the model, and next you need to fit the model with the data. So X is your input data and Y is your output classes. Next you give epochs equal to 10 and batch size equal to 10 and var equal to 0. What are these things? Epochs equal to 10 means how many sequences, how many times you need to train your model. Means how many times your model will see the data. Means if you say a baby that see, this is a car, this is a bus, if you tell him or her, the baby, one time only, he will not remember, right? So you need to tell him or her multiple times, at least 5, 6 or 10 times or 100 times, then it will be there automatically ingrained in his brain that, oh, this is a car. This is, even if you don't tell that, he will understand this is a car, this is a bus. So similarly, this is actually epochs, the number of times you need to train the data. Okay, so epochs, I have trained the data here 10 times. So here also you can fix the number of, this is an arbitrary number time I have fixed 10. The more the number of epochs, the better will be the accuracy. But at the same time, the computational complexity of the computer will increase. Like as I'm having a 6 GB RAM in my laptop, so that's why I'm not running my codes now. I have run it previously and kept for illustration, because it will occupy the entire RAM. And if your RAM becomes busy, this online meeting will get hanged, and then I'll be out of the meeting. Then that's why I'm not running it. I just kept it previously done, so for illustration. So this big code. So this thing also you need to remember, that if you have a very big data set to implement, people go for a bigger size RAM, like 8 GB or 12 GB, that is preferred. And even if you see, for handling large data sets, people go for GPUs in industries and in labs, different scientific labs. People go for GPUs. Okay, so giga processing units, because their RAM is very much. And Ankurji will be doing in Google Colab. You will see that Google Colab provides you a free RAM spacing of 12 GB. So that is, but not more than that. So for handling large data sets, that is a big issue, and the number of epochs you run. Okay, so for handling large data sets, there is some shortcut way also to shorten your size of the data feeding at one time, is to split the data into batch sizes, into mini batch sizes. Okay, so I have split. There are a number of data. I think there were more than 1,000 data also. So in the size of the data. So at one time I'm fitting 10 samples to my. 10 samples to my model. So based on that, I will get the prediction result. And in sequence of 10 models, the entire data set will get fed to our model. So this is batch size actually. So batch size, I will say that give it, or if you don't assign it, automatically it will take the entire data set. Okay, that entire training data set for training. Now verbose equal to 0 I have put. Verbose is actually given to see the running of the epochs, means 1, 2, 3, 4, how is it running. So I don't want to see, I just want to see the results. So that's why these 5 results I wanted to see, and I have got these 5 results. So why 5 I have got? Only 5, where there are more than 1,000 data, that I am also telling now. So predictions equal to model.predict classes X. So I have given I want to predict this data. Now I am predicting the classes X. So for how many how many samples? Here I have given for I in range 5. Okay. So here for I in range 5. So 5 from it will automatically start from 0 and end in just 5 minus 1, 4. So range 5 means 5 variables will be there. 0, 1, 2, 3, 4. So 5 rows are there, and in each row you can see that, as I told earlier, there are 8 features, input features: 1, 2, 3, 4, 5, 6, 7, 8. And then accordingly, if you predict, this is your predicted output, 0 or 1, and expected this was 0, 1 or 0. So this was your actual expected one, and the model that your model is predicting 0 or 1. Now this 0, 0, 1, 0, 1, this thing can vary in different trainings. So the more will be the number of epochs. Let's say if you fix the number of epochs as 100, if you run that, obviously it will take much time to compute the model for 100 times, but you will get a higher stabilizing kind of accuracy, and you will see that this expected value will be very much close for almost all the predicted outputs. Means accuracy has increased. Okay. So some common deep learning models for time series data, we use LSTM, GRU, or 1D CNN. Like my work is based mainly on healthcare data classification. My research work is mainly involves time series data. So I use LSTM, GRU, and 1D CNN in my works. And people who work with image data, they work with 2D CNN. So I'm just, it's not possible to show all the models now. Just I'm briefing what is LSTM. LSTM is actually, for time series data, we use recurrent neural networks. Okay, so LSTM and GRU, these two models, long short term memory LSTM, and GRU is get it recurrent unit. All these you will get in net. Okay, and CNN is convolutional neural network. Convolution happens there. Now LSTM and GRU, these two things are actually recurrent neural networks. Okay, so what are recurrent neural networks? Recurrent means it happens in recurrences, means a time series data. Means suppose you want to predict the from the ECG data of a person, an ECG is data of a person, so let's say is taken for 5 minutes. Okay, so if you see the monitors, where the ECG data gets recorded, as a time as a signal, a time series signal continues to go on, right? We have seen that. So for 5 minutes. So if we from that ECG data, we want to predict whether the person is having any heart problem or suffering from any arrhythmia condition, or whether he's a patient or a healthy person. So, and there are many other problems also that many research statements also based on that. So that thing, for analyzing that thing, long short-term memory. So these are actually the recurrent neural networks. Recurrent neural networks, as I told, occurs in recurrences. Means suppose that there are time steps. Okay, 10 time steps. 1, 2, 3, 4, like this. There are 10 time steps. Suppose. So at the 10th time step, you require the knowledge of what happened there in the 9th time step. And for the 9th time step, you want to have the knowledge of the 8th time step. So previous to that. So recurrences, what happened previous to that. So you based on the previous occurrence, you will get your model will have the knowledge. Okay. So this thing is utilized similarly for the natural language processing domain also, like the sentences. The cloud is clear. Today it's raining very much. So finding the code words like raining, the weather condition, forecasting. So if you want to predict something from a sentence, the grammar, the language, natural language processing thing. So in that case, you also whether the sentence is grammatically correct or not. For those things, you need to understand the sequence of the words, right? So for that thing, you need to understand all the wordings. So that also you need to understand the recurrences. What was the previous word, previous to that. So similar, this thing is obtained by using an LSTM. So LSTM is a special category of recurrent neural network. GRU is also another category. So just to highlight that LSTM, I'm not going into detail, just saying the basic things. It operates based on 3 gates. Like 3 gates are, this is the basic architecture actually. It's available in the net. I've taken this picture from internet. And 3 gates are there: forget gate, input gate, and output gate. So forget, as you can understand from the term forget, it forgets the redundant information. It can analyze that which information to keep and which information to forget. So you can see that there are 3 cells. This is at the t-1 time step, this is at the tth time step, and this is at the t+1th time step. Okay, so the information is getting disseminated from here to here to here. Okay, so there are 3 gates actually inside one. So I have shown this in detail this in this picture, this thing. So there is one input gate, there is one forget gate, and there is one output gate. So forget gate, this forget gate is a sigmoid gate, sigmoid activated. This input gate, it is a combination of sigmoid and tanh, and this output gate, it is also a sigmoid activated. Now from the output gate, you will be getting the hidden state output. So this hidden state output will actually classify any your required thing, whether the sentence is suppose grammatically correct, or if you see a medical signal, if the ECG signal samples will be traveling through all these, the sequence will be fed, the samples at different times will be fed to this LSTM network, and you can understand from the final state that whether the ECG is normal or abnormal. Okay, so I just there's not much time, so I will not explain this thing. Ankurji will take over. So this was a code for the LSTM. Similarly, I imported the model and I imported some functions also. This was actually some of my codes that I did for my purpose. I will just show you this one. Just let me show you this one. I have used the UCI HAR database. Okay, so for the human activity recognition purpose, so I am recognizing 6 human activities: walking down, walking upstairs, only walking, sitting, standing, and lying down. So see, somebody was asking how to visualize the summary. So this one I have printed the summary here. You can the output step and the input step. So this is the summary. Okay, so I printed it earlier in some of my work LSTM. So this is my the summary. This you will get. Okay, so the entire model information. So if you keep verbose equal to 1, you will be getting all these details, the running details, the accuracy, what is happening in which step, epochs. Okay, so at the last, I'm showing you the last output here. See, I think I ran it for how many epochs? I ran it for 100 epochs. Okay, so 100 epochs I ran. So I validated my model. The accuracy you can see, I ran it, the more number of epochs I have ran, the stable the model will become. So I have ran till 100 epochs, so the models continue to become stable from this 20th epoch onwards. Okay, but still I did not stop. I continued. I trained my model till 100 epochs to get a stable accuracy, to get my fit model. So I also validated my model, and the test accuracy I got as 0.0921. If you see here, 0.9209. So that is 92%. Okay. So there are some other metrics also, precision, recall, and F1, which which also gives an indication of how well your model has been trained, just like the accuracy. So accuracy, precision, recall, and F1 score. So these all have mathematical formulas that you can get online. Okay. So this was just a basic thing in this 1 hour duration. So if you have any queries on this, I think I should stop by now. If anybody has any queries, Ankurji.
Yeah, we can take some questions on this. We have explained most of the things, like how we get started with Python. I hope now everybody has an idea that how we start with Python. That is the main goal of this, that how do we start with Python, and how to play with the data structures, and even we have shown one neural network implemented. Yeah, madam, yeah. Somebody has a question?
Yes, please.
Hello, sir.
Yes. Please ask.
Sir, actually, myself, Josephine Anita. Sir, is there any procedure to have this much number of convolutional layers? Sir? Is there any procedure? We can have our own customized convolutional layer. Is there any procedure for this much of convolutional layers should be there? Is there any procedure?
Question. The voice was not.
Pritamji, the question is, she is asking that how do you actually arrive number of layers?
Okay, so number of layers.
Is
that is also,
can you get key only till this much layer I can go, something like that? Can you suggest her?
Acha, means the number of layers, or are you talking about the number of layers or the number of the? I mean,
Epochs.
yes, dense layers. You are
dense layers. Yes, layers.
Layers. Okay, so the hidden layers that you are talking of, that you need to train. The better the you need to see how your model is working. By first, you will continue with the minimum number of layers. Okay, the minimum required. Like suppose say for a deep learning model, we generally start off with 2 or 3 layers. Okay, so but if you see that the model is performing very bad, you need to train the epochs first by assigning 2 or 3 layers. So after that you will assign a very big number, just like the way we go for the numerical methods in programming, like the how we select the particular number. low number or a high number, like the Newton-Raphson rule or the different numbers. We select some particular number initially, right, randomly, and then we come to close, we converge. So similarly here also we need to converge where we get a higher accuracy. So first you need to start off with a low number of, because the less the number of dense layers, the better, the less complex your model will be. But if you increase, like as I have shown here, if you see that, just a minute, in my LSTM model, when I trained this, let me show you the model summary. Yes. So see, when I printed the model summary, here parameter count is there. Okay, so this 44,000, 10,100, and dense, in the dense layer there are six, there are 6 neurons. So the total number of neuron parameters is 606. So all these are countable. Okay, so the more this total number of trainable parameters, the more your complexity will increase, and the more your code will take time to run. So better I suggest that you take this dense layer, this output shape, as less as possible. And if you say of the layers, see, I have used the minimum number of layers. I have used only 2 number of dense layers. There is one dropout layer after the main LSTM layer, and then only one dense layer before the final dense layer output. So only one in the middle. So I can see that there are only 3 layers after the main LSTM. So start off with the minimum number of layers as possible. Okay.
Okay. Any other questions, or I will show some of the another 1 or 2 popular ML algorithms.
Okay. So any other questions?
Okay, Pritamji, let me present. If there are questions, you just keep keep them telling, because we have not much time left.
Right.
And but you have shown most of the stuff, so I hope it's very much clear to all of them. So let me present my screen. Is my screen visible to all?
Yes.
Great. Okay, so thank you, Pritamji. You have actually shown from the basic that how we start using Python, and now most of people here know that this Python is not the real Python. Many people are afraid how we'll code in Python. It's a very, very beautiful language, and you can install it very easily, and you can start off it very quickly. So you must be remembering that Pritamji told he has a 6 GB RAM, and that's why he cannot run the model. And that is where, that's why I thought, okay, let me show you another tool or another compiler where I can, we can run these Python models, which is known as Google Collaboratory. Google Colab. Have you heard of Google Colab? Anyone has heard of Google Colab before or used? Probably not. Then it's a good thing. So some of the beautiful advantage of this collab is that you can share your code. You can share your code with anybody, and you both can parallelly work. So this advantage it brings on. Plus it gives you the power of computation. That is, it gives you the power of GPUs as well as CPUs both. So you can actually run your large models on such systems. And it is very, very similar to Jupyter, and you can code it. It also provides you code snippets, sections, all those stuff. That's why I've opened this. So it's a 0 configuration required. You just have a Gmail. You all have a Gmail. Start Colab right now. Just open it. Write your first Hello World program code. So that is why I use this Google Collaboratory to show the codes. Now to start with, I hope we have people from all over the India here. So I'll give you a very I'll start with one example. How many of you have seen this movie called Swadesh? I hope you all have heard of this movie. It's popularly known as Desam in Tamil Nadu, and South India it is Desam. Very popular movie, 2003 or 4 it has come. So there was a character in here there was a character in here which says ki, by seeing the clouds, that character says ki today it will rain or not. So that was human intelligence. I'm not sure how intelligent was that person, if you can remember that scene from that very popular movie. But few years later, or we have this artificial intelligence which actually can tell you whether it will rain today or not. So that is why I've taken this example that, okay, let me show you a code where based on certain data, can we say that how much rainfall will happen today? So, weather forecasting is a very, very popular machine learning, deep learning or AI based task. And, in your Google also you see ki tomorrow there will be a rain or not. So they basically use these machine learning stuffs only based on the previous data. And, LSTMs, as just now Pritam ji has shown, is one of the most popular algorithm that was deployed on your phone. It has actually come from 1999. It has been long used. LSTMs are very, very powerful. So I'll show you that can we, predict that amount of rainfall that will happen on a particular day. So right now, all of these libraries are already shown by Pritam ji that you have to import pandas as PD. PD I am doing here. I'm importing NumPy. And as I'm using scikit-learn here, so I'm using sklearn also. And from this sklearn, I am importing linear regression model here today. So all of you, most of you must be knowing what is a linear regression model or what is a linear equation. Can anybody tell me what's a linear equation? Why it's a linear model? What comes into your mind when you hear linear regression?
Variables are linearly dependent.
Variables are linear. That is the first thing. Yes. So if I give you a quick example, if your height is more, there are quite chances that your weight will also be more, right? But so what's that beautiful equation that comes onto the mind when you see a linear model?
Y equal to mx plus c.
Perfect. Y equal to mx plus c, y equal to ax plus b, all those answers are correct. So what you actually need here, now you people are actually answering in a linear regression model. You need A, the slope, and the intercept B. The M and C, if you can, you can, get the line. And when you know the line, a new data set comes into the picture, a new variable comes into the picture, you can predict as they are linear, this will be its value. So this is very beautifully exploited by, Python libraries. And we actually estimate A and B using methods such as ordinary linear least square. Have you heard of least square? Anyone of? I hope you all have heard of least square method in linear algebra. Gradient descent. If not, this must be definitely, it will be covered here in your AI sessions. So these methods enable you to actually compute these coefficients A and B. So the power of Python, the libraries, machine learning libraries, comes here. When I import this sklearn linear model, linear regression, this model will actually compute all this for you. You need not to do handwritten calculation, but you should learn it using handwritten first. So I have imported all these libraries. Matplotlib already told by Pritam ji that what it does, it is used for plotting. Now what I'm doing is, it's a very popular data set, Austin weather data. You can Google it, download it from Kaggle. Kaggle is one of the websites you all should visit for the data sets and the basic codes. It's a very basic code which I'm showing right now. So this data set you have to upload on Colab. So what you will do, from Google Colab, import the file, and you have to just run this code, and it will prompt you, ki, where is your file? So I have already imported it as austinweather.csv. So this file is now in my Google Colab file. So first thing, what should we do? We should store it in data. Let us see how my data works. So I think most of the commands are already shown by Pritam ji. I hope I am writing the right command. Let us see how does my data looks like. Oh, so you can see this is the data set. It has a lot of frames, 1319 rows and 21 columns. Many are redundant. Events are not there. It's a haphazardly collected data set. Somewhere I have T, somewhere I have this. But I now get a picture. Okay, this data set contains of temperature, pressure, precipitation. So I will try to use it for my rainfall prediction, that if this is the situation, what will be the rainfall? Okay. So there will be a lot of unknown data that we don't want actually for rainfall prediction. So this step is very popularly known as data cleaning. So I'll be cleaning that data. So I'm dropping such as events, date, sea pressure, high inches. These are like redundant data are not required for my rainfall prediction. So I have done this. Now if I see my data, it will look little beautiful. You don't need to oh, I think I have to run it again. Yes. So now somebody has a question? No. Okay. So now you can see the previous data set was haphazard and you don't know what's happening here. Now you can see a little bit clean data, but still we have instead of we have some extra variables t and also let us remove those also. So you replace t with 0. It's a trace that hardly any rains have happened. So they've written t here, the scientist. So I have run this also, and I have replaced where there was 0 values. I don't want those values. So this is basically I have done the data cleaning, and now I have the final file, which is Austin_final, the clean data I have. It is very important. Data cleaning is very important in any machine learning stuff. Now, once you clean the data, again, you have to read it, as all these commands are already shown before to you. So we have now read the data. Now data is read. Okay. So what do we want to predict here? What I was telling you to predict? I hope people are with me, or it's lunchtime probably. So what I was predicting, I hope somebody should answer this, otherwise I am predicting, or I am estimating rainfalls. Yes. Thank you for being with me. So I'm predicting rainfall. So if I'm predicting the rainfall, that is how much rainfall is happening. So I am actually dropping it from my features. It cannot be on my feature. Feature will be the other parameters. So I'm dropping it from my data.drop, and I'm giving it to my y-axis, that this is my label that I want to predict. Okay. So let us now choose that. Let us choose a day where, let us see what happens on this particular day, the rainfall. So I've chosen from the day. These are, very basic data operations that you do. I've chosen the day index as 798 here from this complete set of data set. And now the most important stuff here is you need to just call a linear regression model. Classifier is your linear regression, and you have to fit it on X and Y. If you are doing it manually, you have to write the whole least square code or the gradient descent code. But in Python, the power of Python is that you just need to call this, and it will actually fit the data. Ayyo, it is not. Some error. Okay, I have to run everything. That's it. Run it from start. So it's a sequential operation, so you have to run everything. I hope it should run. Yes. So now your linear regression model has been trained. The model is trained, right? So you can see that your intercept has been calculated. You don't want to run any parallel jobs, only single job was there. So now let us see that there were so many features, that what is the temperature today, what is the humidity today. So all these parameters I'm entering here in my array. So if these 17 parameters I have entered, so what will be the rainfall? Since it's a regression, so it will give you a value of the rainfall. So let us say, based on these inputs, what will be the output? Something is good. Let me run the whole code. There might be something. So basically based on these values, it will actually tell you, I have run this code before, it will give you that, okay, the rainfall today is 1.33 inches. It comes like that. So you can change your all the parameters of your regression model and actually predict the output, that the output is this. I hope it comes. If there is an error, I need to check it and I'll send you the code. It's running. Okay, it is asking me the file. So I have to upload Austin weather file on the data set. It's 100% done. Perfect. So the precipitation in inches for this input is 1.33. Let me change some parameter. Let me write here 29. I hope, let us see what happens. The precipitation has changed. So see how important is this parameter. If this was humidity, or let us say, if this was humidity, if humidity is less, I have reduced the humidity, the precipitation has changed. So you can see here that how machine learning is actually giving you this output, that you can actually get the very closer values, that whether how much rainfall will happen or not. So this is one of the very popular example for the rainfall prediction or a weather. Similarly, you can take temperature prediction. You can take, this is very useful for agriculture IoT tasks. I have used in one of my researches where I have predicted that which locations are important to be irrigated. So I have collected the data related to soil humidity, soil pressure. So I have inputted all this here, and I can actually check that this much, rainfall is possible today, and accordingly we can act. So this is one of the very popular thing. Another very popular algorithm is that we use is K nearest neighbor. Have you heard of K nearest neighbor, or is it has been taught in the previous lecture? KNN. Anybody knows what is K nearest neighbor? Have you heard of KNN?
Yes, we check for the k nearest values and accordingly we set for the current one.
Exactly. So how do we, what's the distance? What's the metric that we actually see? That is the key here.
Distance.
Distance. Yes. So you see how closer is the new value. Now, this was regression. So we were actually getting the values. Now we'll be doing a classification. For example, you got a new sample and you want to see whether this, I'll give you a example that we all know, that let us see we have different sizes of shirts, and we get a new customer in the shop, and he tells something about his height, something about its weight, and then my model has to tell that he will wear a 42 number of shirt or a 40 number of shirt. So we'll take those examples, compute this distance. It can be a Euclidean distance, it can be a Minkowski distance, Manhattan distance, any type of distance you can choose. And then you can actually see that, okay, this, it will suggest you, it will actually, bring you closer to that particular shirt size. So I have also, done this simple program here where I will predict that whether this person was having the cardiac disease or not, which recently Prigamji also has shown. So for that, I have to choose a heart-based data. So this data set was like this. In this data set, I have age, whether male or female. So this person had a chest pain or not. He had what sort of blood pressure he has, cholesterol, rest ECG, thalach, that what maximum heart rate it achieves. So based on all these, can I tell if I have some of these data whether this person will have a heart disease or not? Okay, so see, in machine learning you are actually requiring again, all these features, many manual features you need actually. But in deep learning, things will be a little different. You will have a minimum amount of data, and your algorithm will be automatically computing the features. So here I have these features now. So what I did, very similar to what I was doing here, I have imported the libraries. The few new libraries that I will import here is there I was using linear regression. Here I am importing k-neighbors classifier. So again, the task of computing the distance and everything is already done because of this library. That is the advantage here with the sklearn or the scikit-learn, that you already have imported this. So let us run this. This time I'll run everything, otherwise it will again give you error. Let me run this libraries, load the hard data. So let me load the file. Okay. It should load, then it should say 100% done. It's done. Then I'm importing it into the data file. Okay. So let us see how does my data looks like. Okay, this time I have test BP, cholesterol, all this stuff. Okay, these all are required for my target. Very good. I have 303 rows and 14 columns. So let us see how many actually let us see the count. It is very, as everybody is telling, first see your data. Let us see how many we have people in this all data set that have disease. So I saw that target one, that was disease, we have around 165 people, and there are 140 people which do not have disease. So I have to actually correctly classify out the sum of these two, that whether if the person has disease, it should predict that it has disease. If person do not have disease, you should predict it do not have, or it does not have disease. So now I'm doing all this, I'm understanding the data. Let me see that how much maximum heart rate is there, because these analysis is very important for any machine learning engineer. So what I see here, can you see this plot? That scatter plot. It's a very beautiful plot. What does it tell? Can anybody tell me what this scatter plot is telling? Any quick observation?
Negative correlation.
Yes, very good. One is negative correlation. Another very key thing here, which a human is seeing, is you can see in 50 to 60 age there is a lot of density for diseased people, which actually happens also. These days young people are also having cardiac, that's fine. But so I'm getting a data 50 to 60, in between I'll have heart rate is too much, and even these people are getting disease also. So I have got a picture of my data. Now I will, as usual, like the last time, I will put features on X, and what I want to estimate is on Y. So I have done that. Now another thing which Pritamji also told, that you want to test your model, how accurate it is. So what you will do, it's a supervised learning which must have been taught recently to you, or it will also be explained. So in supervised learning, you already know that this particular sample had this particular label. This particular person will have disease or not, you already know. So what we are doing is we are actually splitting the data. So we will train on a particular model. And what I am doing here is that I'm training it on 75% of the model, and I'm testing on the 25% of the model. Now this all stuff you need not to do manually. You just have to call xtrain, x comma test, ytrain y comma test, and use this train test split. That is why I had this library here. I have imported train test split. So you see the power, that's what we are talking of, the Python. Okay. So I have now splitted the data. Now on this 25% of the data, let me see whether my model has worked or not. So same, I'll be fitting my k-neighbor. Another step before that, since you can see here that data has come from different dimensions or units. Some unit will be more, some unit will be less. So ideally, it is a thumb rule for any machine learning engineer or any statistician that it normalizes the data. He or she normalizes the data. So you can use, in Python, you can directly call this standard scalar library. It basically does a lot of operation. It subtracts your data with the maximum value, and then divide by mean. You can divide by standard deviation, so that you get it between 0 to 1 or a standard value. Otherwise, the model will learn, but it will not be that efficient. So we do the standard scalar. This is a very very popular library that on the data set we apply this. So we applied this, and now we are calling our k-neighbors. So in my case, how will you choose the number of k? That is the question that most of the researcher wants to know. How do you choose number of k? But how many neighbors you actually want to check? Any idea? Okay, so let me quickly tell this. Probably, I think it's almost time. So you see, most of the time it's like people try with different values of k. It's do the experiment and they see where the error is least. They choose that value. That is one way. There is an elbow method that where the error is least, you actually choose these values. So for this one, I'm choosing 7 neighbors and computing my distance using the mean Swasey distance. Just to show you, I've done that. Let me run this classifier and fit for the k neighbors classifier and see what is the accuracy. So if I see the accuracy, it is 87% accurate. Let me change the number of neighbors. 5. And see the accuracy. Oh, 82%. So you can see number of neighbors are very important, that around this new sample, how many neighbors you are choosing to compute the distance, and then classification. That is very, very important here. So see, n neighbors are actually changing the accuracy. If I choose 2 only, let's see what happens, whether it fits or not overfits. Let's see. Okay, accuracy has decreased. And when I choose 7, this is the maximum accuracy that you get of this. So you can choose, you can tune your hyperparameters and get these accuracy actually. So this is a very, very what this tells, that 87% accurately my model is telling that this person has disease or not. It has classified correctly. Fine. So I'm done with these 2 examples, and we are also almost, it's time. So we can take any questions you want to know about machine learning research, the sessions that we took, and anything you want to know, any doubts. We are open.
Ankurji, there is a question.
Yes, for you, I think deep learning model.
What is the minimum size of data
Yes.
that we should consider to develop a deep learning model? Okay, so it depends on the data set actually. Okay, so means there is like the different splits we use for training. If you would observe in different codes, we for the entire data set, we either do a 70-30, we do the split in the ratio of 70-30 ratio, or in the ratio of 80-20 or 60-40. It depends. But now the question is, what is the minimum size of data, right? So actually different data sets have different sizes. So there are problems. So I will say that the large the data set, the better it is to get, means the number of examples you
Yes,
get to
yes.
learn. So
For
better it is.
deep learning is
Yes.
data hungry, and
Means like the same example I am going back for a baby. If you train him with the different kinds of colors, then he will get to know he will learn more. The more you read, the more you learn. The same concept applies here also. The more is the data, the better the model will be. But there is a situation when there is a minimum, when we have less amount of data, right? So
Yes.
the data crisis is there. So in that case, there is also a solution called like cross validation. Okay, so like if you see, there are some techniques called k-fold cross validation, or one cross validation. So in those cases, means you have to split the data in different k-fold cross validation. In suppose 5-fold cross validation you do. So and if you have 100 data, so you will split the data in slabs of 20. Okay, so 20 cross 5 gives you 100. So in every step, you will do 20 for testing and rest 80 for training.
Yes.
Okay, so similarly in the next step, the 20 that you used for testing in the previous step will now be used for training, and the rest and any one of those 80, any 120 out of those 80 will be now used for training, testing. So like this, you will after you train 5 times, you will also be having a testing of 5 times. So then you will be averaging all them, and that will be a kind of called 5-fold cross validation. 5 times means 5-fold cross validation. So multiplying the things. So you are actually the same data number of data, different segments of data, and training with different segments of data of the same data set. So, but this is the disadvantage of a small data set. So what to do? We need data, right? So in case of data crisis, we have to do this thing only. So I hope
Thank
that
you,
answers
thank you.
the question, right?
Yeah. I hope it has answered. And basically, Mahesh ji was asking ki minimum. Actually, there is nothing like no minimum. There are fast data signal processing techniques also. Many methods we use. You can increase
You
the
will
size
get
of
the
data
results.
also. Yeah.
You
You
will
will get the result, but
results,
that will
but
not be
not
accurate.
that good. But not that good.
Like I gave you that example of that movie, that guy in the picture, he just used to see the clouds and say something, and everybody in the village was assuming that it will rain, and he was always wrong actually. So that's why data is the more the data, it is better. But yeah, it should not be again, it should be quality data. The data should have the value. That's why in my example I removed redundant data and the data that was not required. Any other questions?
Any other questions, participants? No, I think there is no question.
Okay.
Right? Okay, both of you, Pritam and Ankur.
Thank you, sir.
Thank you for giving a very nice
Thank you, sir.
talk.
I hope we were able to convey at least the basics.
Yeah. It was a very informative and very interesting talk.
Thank you very much.
Okay.
You can check the Sensor Networks Research Lab web page. You can find our IDs over there, and sir's email
Yes.
ID is there. You all can write if you have queries and all. So you can just check Sensor Network Research Lab IIT Patna. Sir's page is there and our lab is there. Thank you. So we are signing off, sir. We are signing off.
Okay, sir.
Yes.
Okay.
So
Thank you.
participants, there is a lunch break now. So next session will be at 2:30.